welcome to True Projects. In this video, we are going to explain about the project that is hybrid machine learning model for efficient botnet attack detection in IoT environment. Before getting into the execution, first let us understand what is the project about. So we all are familiar with the term called internet, right? So internet, it has become a part of everybody's life. It is almost that everything we do, that may be from talking to friends to shopping, banking, or even running a business. It is amazing that how it connects the world. But this connection also opens the doors to serious problems. One of the biggest threats is something called botnet attacks. So these botnet attacks are like an army of hacked devices that are computers, phones, even smart gadgets at home like cameras or thermostats that have been secretly taken over by cyber criminals. These attackers use this army to do all sort of bad stuff like crashing websites by flooding them with the fake traffic DDoS attacks, locking up people files for ransomware, stealing the data or spreading harmful software. It is scary because it is not just about breaking a system, it also makes people lose trust in the internet which we rely on so much every day. So these botnets are tricky because they keep changing how they work and also finding clever ways to avoid being caught. It is like they're always one step ahead of usual security systems. This is even more of a problem in IoT networks that we know those billions of smart devices like home assistants, cameras and even appliances. These devices constantly send and receive data, creating a super complicated traffic patterns, analyzing all of that to spot something fishy, and it is really tough. So the biggest issue is that traditional detection methods often can't keep up, especially when new types of attacks pop up. This makes it hard to catch botnet attacks in the real time before they do the damage. So here where deep learning comes into the picture. So this deep learning, it's like giving the system a superpower to automatically find patterns and connections in the raw data, even ones that aren't obvious. This makes it possible to adapt quickly and tackle these constantly evolving threats more effectively. So this project is all about building a system that can detect botnet attacks, which is just like trying to spot when something malicious is happening in the network. Imagine a network under attack. The system helps to figure out whether it is just normal traffic or if there is botnet involved, which can cause the real damage. So, what interesting here is how the system works. Instead of relying on just one kind of model, here we combine best of several deep learning techniques that are artificial neural network, convolutional neural network that is CNN, long short term memory LSTM, and recurrent neural network called RNN. Together, these models form what is called as ACLR. So we call ACLR that is combined with the ANN, CNN, LSTM, and RNN. It's like using different tools in a toolbox to tackle a problem from various angles, making the system more powerful and accurate. So for training and testing the system in this project, we are using UNSW NB15, which is a collection of network traffic data. And this it is processed by, I mean, here we have processed the data by cleaning up null values, which are nothing but the missing values, and organizing information for easier analysis. Once the model is trained, we evaluate them using accuracy, precision, recall, FN score, and ROC AUC curve. That is nothing but receiver operating characteristic area under curve. So this helps us to understand how well the model can detect botnet attacks and tell the difference between normal and malicious behavior in a network. In short, our goal is to make networks safer by quickly spotting and dealing with the potential botnet threats. And here to further improve the performance, we are using hybrid approach. So here we are using one more hybrid approach of deep learning model where we mix up CNN, LSTM and GRU, that is convolutional neural network, long short-term memory and gated recurrent unit, that is nothing but GRU, to create more powerful hybrid combination. And also we have used CNN by LSTM and GRU. So these models like using a few different experts in the field, each focusing on different aspects of the data, and together they can capture more complex patterns in a network traffic. This helps to improve the system's ability to detect attacks and makes it stronger against new or evolving threats which are always changing. Additionally, we have developed user-friendly and interactive front-end using Flask framework. This would gives users a simple way to interact with the system, test its performance, and it's like creating a dashboard where people can see what is happening on the network and understand its whether there is an attack or not. Plus, in the front end, we have included user authentication mechanism. So this makes sure that only authorized users can access it, which adds an extra layer of security. It adds as an extra layer of a security and helps to ensure that system is safe. So this makes sure that only authorized users can access it, and this adds an extra layer of security, helping to ensure that system is safe and reliable to use. Moving to the implementation, we have followed the steps in the flow of work. So, coming to the first step, first we start by importing necessary Python libraries and packages such as Pandas, NumPy, scikit-learn, and deep learning libraries. Then the next step is exploring the dataset. So, here in this step, we load UNSW-NB15 dataset to understand its structure. This includes examining features that are columns, data types, and check for any issues such as missing or irrelevant data. Then we do necessary data pre-processing. Here we identify and remove any duplicate records in the data set to ensure accuracy, and we drop columns that are irrelevant to analysis or have too many missing values. Coming to data visualization, here we visualize the data set to gain insights into the distribution of features and identify patterns or anomalies that could indicate botnet activities. Then the next step is converting categorical labels to string values. I mean, categorical or string values like attack types into numerical values to make them suitable for machine learning models, because machine learning models will be only able to take the numerical data. That's why we convert categorical or string to numerical. Then the next step is selecting the extracting the features. Here we separate dataset into features as X and target variable as Y. Features are the input data and the target variable is what we want to predict, whether there's an attack or not here in this case. Then the next step is feature selection. So here we use mutual information to select the most relevant features that contribute significantly to predicting the target variable, reducing noise and also improving the model performance. Later on, we split the data into training and validation sets, ensuring that model can be trained on the part of the data and evaluated on the validation part on another to avoid overfitting. Then, we initiate multiple machine learning and deep learning models to classify network traffic as either normal or under attack. Then we train the models using training data, allowing the algorithm to learn the patterns and features from the data. Then we evaluate all those using accuracy, precision, recall, FN score, and ROC AUC curve graphs. Then we evaluate them, I mean, we compare them through the graphs. Coming to the part of front end, we develop a web interface using Flash framework where users can log in, input feature values, and interact with the system. The SQLite database stores user credentials securely. And in the front end, users they will be able to give feature values related to network traffic attributes through the front end interface for botnet attack prediction. And that input will be pre-processed at the backend. I mean, here we pre-process the user input to match the format expected by the train model, ensuring data is clean and properly encoded before making for prediction. And then we use train model, that is train deep learning model, to predict whether the user input corresponds to a normal attack behavior or botnet attack. Finally, outcome will be displayed through the front end of the interface. Coming to the algorithms used, these are the algorithms used in the project to classify the attacks. So this is the proposed model and this both are the extension models. Coming to the requirements to implement this project, we need basic hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let us execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Here in this folder, we have the dataset used in the project. And then this data set will be used to train the models. We will be pre-processing, then we will be training the model. Coming to static folder, in this folder we have files related to CSS, JavaScript and Bootstrap files which are important for the visual appeal of the project. Then we have a templates folder. In this, we have HTML pages that are used in the project. They include files like index.html, about.html, etc. They represent different pages of the website. And we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Then we have multiple model files which contain the algorithm information. This will be loaded into the project code during runtime of the application. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here is the processed file. So originally we had this data, main data, raw data in the archive folder, right? And here this is the after pre-processed data set. I mean, here we have pre-processed the data set which is in the archive folder, and then we have saved it in this format. So this is the pre-processed data. This we will be using to train the model. Let's close this. And here we have signup.db file. This file is a database file which is used to store the user information. And this is the sample file in which we have test cases to detect the attacks in the front end. Now let's copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So it has been opened. Give the command cd followed by the space and paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folders path. Now compile app.py file, give the command python space app.py. Now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So now copy this local link provided by the Flask framework and paste it into any web browser. I've copied the link. I prefer Google Chrome, so I will paste it in that. Let's paste here. Click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now let's sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So this is the prediction page of the project where you can see multiple parameter right. We need to enter all these parameters. Based on that, we will be getting the prediction. So first we have is the S bytes that are nothing but the source bytes. This represents the total number of bytes sent from the source, that is nothing but the client, to the destination, that is nothing but server, in a given network session. It is an important feature for analyzing the amount of data being transferred. Then we have D bytes, that is nothing but the destination bytes. This indicates the total number of bytes received by the destination, that is a server, from the source, that is client, during the session. It helps to assess the amount of data being received. Coming to rate, it is the connection rate. This is the rate at which packets or bytes are transmitted between the source and destination over the network. It gives an indication of the traffic speed or volume. Then coming to DIN PKT, that is destination input packets. This parameter represents the number of packets received by the destination device in a given period of time. It is useful in assessing the network's load and packets traffic at the destination. Then we have is the TCP RTT, that is nothing but TCP round trip time. This measures the time taken for a TCP packet to travel from the source to the destination and back. It is a key indicator of the network's latency or delay. Then we have is the SYN that is nothing but the SYN ACK packets. This refers to the number of SYN ACK packets which are used in the TCP handshake process to establish a connection. This is important for understanding connections, establishment times, and etc. Coming to ACK DAT, that is nothing but acknowledgement data. This represents the data received, that is the data sent by the receiver as an acknowledgement, that is nothing but ACK, in response to the data packets received. It's part of the process to ensure reliable communication. Then we have is the S mean, that is nothing but the source mean. This is the average value of packets or bytes sent from the source. It helps in understanding the typical amount of data being transmitted from source during a connection. Then we have D mean, that is nothing but the destination mean. This is the average value of packets or bytes received by the destination. This is similar to the S mean. It reflects to the average rate or volume being received by the destination. This is all about the parameters. Let us enter them. So we have that in the test cases. Let's open test cases. Open the sample file. We have these many test cases. So total we have 31 test cases. We can try with any of these to predict the attack. So let's try with the first case here, where source bytes we have is 734 source bytes and we have destination bytes of 42,014, and next rate it is 78.47, and DIN packets are 15.43, and the next three values are, that is TCP RTT is 0, SYN ACK is 0, ACK DAT is also 0, and S mean we have is 52 and destination mean we have is 1106. Now let's click on predict and see what will be predicted. So click on predict. And the input will be pre-processed at the backend, and then the train model will be giving us a prediction. So here we got the prediction that attack is detected, and that attack type is DDoS attack. It may be DDoS attack or any other type of attack. Now let's try with the second case. So click on prediction again, where source bytes are 364, destination bytes are 13,186, and the rate is 14.17. DIN packets are 102.73. TCP RTT is 0.111897. And then we have SYN ACK. Let's copy it and paste it. And then the next value is ACK DAT value. So paste it here. S mean is 46. And D mean value is 824. Now let's click on predict. So here we got the prediction that attack is detected and that attack type is DDoS or any other type of attack. Let's try with the class 3. Click on prediction again. So source bytes are 628. Destination bytes are 770. Rate is 13.6. DIN PKT is 90.23. And the next three values are 0. So enter them as 0. And then we have S mean is 52 and D min is 64. Now let's click on predict. So here we got the prediction that there is no attack detected and it is normal. So here normal, I mean there is no attack. So here it has detected as there is no attack. Let's try with this case. So let's try with this case. That is the 31 case. Click on prediction, where source bytes are 828. Destination bytes are 1346. Rate is 55.18. DIN PKT is 35.121315. And next we have TCP RTT value. So copy it and paste it here. Then we have is SY NAC. Then ACK DAT. S mean is 83 and D mean is 168. Now click on predict. So based on the given input here, we got the prediction that attack is detected and that attack type, it may be DDoS or any other type of attack. So this is how you need to do the prediction. Now let's check with the graphs. Click on graph. So here the first graph which we have is the sample outcome graph, which shows the distribution of the target variable. So here on x-axis, we have the classes that we have predicted in the project, and on y-axis, we have count. So 0 refers to no attack and 1 refers to attack. And this is the correlation matrix. This shows the correlation between individual variables. And this is the accuracy comparison graph. So here All the models are trained on the UNSW-NB dataset for classifying the attack. Here on x-axis we have accuracy of each algorithm, and on y-axis we have that particular algorithm name. And this is the precision score comparison graph. This is recall score and this is FN score. This is ROC AUC graph. Now let's click on logout, that is sign out. In this, which is by giving input, that is parameters to the system, it will detect whether there is attack or not. This will help all the users to overcome from the cyber threats. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.